So like I was explaining a minute ago, we're going to do the growth. We're going to spend a few days on growth and decay. Okay? An exponential function is a continuous function with a variable as the exponent. So we're dealing with exponents. Okay? A linear function, it increases at a steady rate. Like, you know, you're putting money in your drawer at home, $50 a month. Like, you're not getting any interest because it's just your drawer at home, right? It's not a bank. Okay, so it's just going to steadily climb at a steady rate. But growth goes faster. It gets faster and faster and faster and faster. Or it gets higher and higher and higher because like if you do put the money in the bank, then you're getting some interest. And the interest goes back into your account, and that's more money. And you'll probably understand that better as we go along here, hopefully. Okay, so growth, y increases as x increases. Decay, y decreases as x increases. So that was a bad picture right there I just drew. But that's decay. This is growth. Okay? So for both growth and decay, did y'all pick up the notes? Y'all have the notes? Okay. Okay, so for both growth and decay, we have an A and a B and an X. Okay? A and B and X. So the A stands for the initial amount. Okay? So maybe you got $500 at Christmas, you're going to put it in the bank, okay? And grow some interest. 500 would be your A. B is the growth factor. Okay? So, we need to write a couple of notes down here because you might need to use these. Okay? B is 1 plus the rate. So if we did a little algebra on this, the R would be B minus 1. So you need to write both of those down. And it'll make sense in a minute, hopefully. Okay, R is the growth rate. It's usually in a percentage, but then you change the percent to decimal. Okay? So the R is either in a percent or a decimal. Okay? Okay, so let's talk about decay for a second. So decay is if something were decreasing. So you were sick and you took some antibiotic, you took some medicine that the doctor prescribed, and it caused the bacteria in your body to decrease. Okay? So A is the initial amount, the same thing, the amount of maybe bacteria you had in your body. Okay? B is the decay factor. So our B is 1 minus R, because see they have in place of B here, that this is your B, and this is your B here. Okay, they broke the B down for you. But then to find the rate, okay, you do 1 minus B. Instead of B minus 1 over there. Okay. And R is the growth rate. Again, it's in a percent or a decimal. Okay, so let's just kind of dig in and you'll see how this works out. First of all, this is your A, your B, and that's your X. X is the time. It probably really should say this up here, that X is your time. Okay, we might want to add that. We could add that. X is time. Let's add that. X equals your time. So it could be in years, months, days, hours, minutes, seconds. I mean, it's going to tell you in the problem what it is. Alrighty? Okay, so first of all, is this growth or decay? You look at the B value. And if the B value is bigger than 1, B is bigger than 1, then you know it's growth. Think about it. If you multiply something by 1, it stays the same, right? You have some money in the drawer, $500 in the drawer. 500 times 1 is still 500. Your money didn't grow, did it? But if you multiply your money times 2, 500 times 2 is 1,000, right? Okay. Well, what if you multiplied your money times something between 1 and 2, like 1.1? Okay? Your money would grow, right? Anything bigger than 1, when you're multiplying by anything bigger than 1, it may not be a 2 or 3 or 4. It might be a 1 point something, something, something. It's going to grow. It may be a little bit, but it's going to grow. Okay? So if this is bigger than 1, it's going to grow. So the initial value, something started out at 2. We don't know what they're talking about here. The B is 1.25. The rate is 0.25 because you take the B and you subtract 1. Okay, that gives you the R. So 1.25 minus 1 is the rate. So I just subtracted 1 right there. Okay, just subtract 1 and you get 0.25. And the percent is 25%. So something is growing at 25%. So very few things, your money doesn't ever really grow at 25%. That would just be unheard of. Okay? Okay. So then, let's look at this one. Okay, we don't really have an initial value here, so that's 1. Okay? Okay, so is this growth or decay? It's decay because our B is smaller than 1. Okay? So this is decay. So you have to circle whether it's growth or decay. So our initial value, something starting at 1. Okay? Now, our B is 0.25. It's whatever's in parentheses. You don't have to do any calculations to figure out what the B is. Okay? The R is, what does it say on up there in your formula? How do you figure out R up there in your notes? R is 1 minus B, right? So 1 minus 0.25 is 0.75. So think of 100 minus 25. 100 minus 25. That might help you because you're going, oh my gosh, those are decimals, I can't do them. Okay, think 100 minus 25 is 75, so it's 0.75. Okay, so something is decreasing at a rate of 0.75, which is 75%. So the growth to me is easy. I just get rid of the 1 here. Oh, that's my growth rate. Just get rid of the 1. Okay, get rid of it. Or subtract 1, because you're going to find some on your worksheets that have a 2 there, a 2 here, and so you're just going to subtract 1. I think we have one in a minute on our notes. Okay, so let's look again on the next page. And it spins and spins. Okay, so now we have something here. Okay, there's a 1 in the front. A, B to the X power. A, is this growth or decay? This is growth, okay, because it's bigger than 1, right? B is greater than 1, so it's growth. Okay, what was the initial value? A 1. Something started at 1. We don't know what. Okay, what is the B value? 1.15. Okay, what's the rate? You take 1.15 minus 1. Gives us the rate. So what is that? 0.15. So just cover up the 1 with your hand, with your finger. Just cover up the 1. So it's 0.15 and then 15%. Okay? Yes. No, they're not asking for the time. And they're not asking us to work one. We are in a minute. They're going to ask us to work one with time. Right now, they're just trying to help us. I think the point of these problems right here is to figure out, is to get that R down, get that rate down. Okay, so again, is this growth or decay? This is decay because this B value right here is less than 1. Okay, B is less than 1. So it's decay. What's the initial value? 1. Okay. What is the B? 0.43. Okay, so to find the R, you take 1 minus the B. So the R is 1 minus 0.43. Just in your mind, 100 minus 43. What's 100 minus 43? 57. So 0.57, and then 57%. Okay? Okay, let's do another one. So here's one where it's not a 1 here. It's not a 1. It's a 2. So this is going to help. There's a couple like this on your homework, so be careful right here, okay? Okay, so is this growth or decay? It's growth. It's bigger than 1. There's our B. There's our A. What's our initial value? 8. Something started at 8. Now, you'll find in a minute, like that could be 8 billion. We could be talking billions here. We could be talking millions here, okay? You know, we don't know what, or thousands. We don't know what they mean. Okay, what is our B? 2.59, okay? Now, what's our rate? Yeah, B minus 1 is our rate. So 2.59 minus 1 is our R. So 1.59. So always just subtract 1 here. So 1.59, which is how much percent? 159%. So something is growing super duper fast. Again, like maybe bacteria in your body or something. You know, when you get an infection, you get sick. You know, I don't know if bacteria in your body grow that fast, but, you know, we can pretend. Okay, so is this growth or decay? You look right here. Okay, yeah, B is less than 1, so we know it's decay. Okie doke. What's our initial value? 2. There's the A right there. It's 2. Okay, the B is, you just write what's in parentheses. Okay, when it's decay though, your R is 1 minus the B. Okay, so your R is 1 minus 0.61. Again, think in your head, 100 minus 61 is 39. So 0.39, 39%. So something is decreasing at a rate of 39%. So hopefully, once you start taking that antibiotic from the doctor, you're decreasing that nasty bacteria in your body that's making you sick. Maybe you're decreasing it at a 39% rate. I don't know. I have no clue about all that, but I'm just kind of playing around here. Okay. So now a couple of little word problems. So the world population in 2000 was approximately 6 billion. The annual rate of increase, so that would be growth, wouldn't it? You have to kind of find those key words that sound like something's growing. Growth was about 2%. So this is our rate, 6 billion. That's our initial amount, right? And then 2000 is going to be part of our time. We're not sure yet. We got to kind of keep going. Okay. Find the growth factor for the world population. So the B is 1 plus the R, right? You add a 1 to the percent. Okay? So the B is 1 plus 2%. But I need to change that 2% to a decimal. That's right. Okay? So 0.02. So don't say 1.2. It'd be 1.02. Be careful there. Okay? So B, the growth factor is your B. Okay? Look on the front page, the definitions. So we found our B. We found our growth factor. It says, suppose the rate of increase continues to be 2%. Write a model or a function to model the world population growth. So now we're going to write it in the form of y equals ABX. Okay? What's our initial amount? What did it start out as? What did this population start out as? 6 billion. But I'm not going to write 6 billion. I'm going to just write a 6. And I'm going to know my problem is in billions. Okay? What's our B? Well, we just figured out our B. And then our time. Okay, now to answer Gabriel's question earlier, let's do one with a time. What was the estimated population at the end of 2018? So we take y equals 6, 1.02, And then from 2000, because it started out in 2000, right? From 2000 to 2018, what is going to be our population? So you go to your calculator, okay, and turn it on. Okay, you type in 6 times 1.02, and then you have to do an exponent. So you use I call it a carrot top, but y'all might call it house top or rooftop or whatever. It's underneath the clear, okay? I think in the old days it's called a carrot top. So that means you're raising that number up, okay, to the 18th power. Enter. So we get 8.56. That's an estimate. We're rounding. And this is in billion, isn't it? So if the population continued to grow at 2% a year, in 18 years, we would go from 6 billion to 8.56 billion. That's what that means, that question. Uh-huh.
How you know, like, what is what and where comes?
Okay. Yeah, you kind of missed out on the beginning, but, okay. The A part is your initial value. Initial means beginning. So what did you begin at? You began at 6 billion. Okay? This is your rate. To find your B, because it's y equals a b to the x. Your A is your initial value. It's 6 billion. To find the B, which is what we were doing here, you add 1 to it if it's growth. Okay? 1 to the 0.02, to the 2%. So our B is 1.02, and then when we read the problem at the very end, it said in 2018. It says how much time has passed by between 2000 and 2018, so we put our time here. This is our time. Your x, your exponent, is your time. Okay, so let's work another one and see if we can figure out what's what, okay? Okay, so a computer valued at $6,500 depreciates. What does depreciate mean? It means go down, drop down. It's like decay, okay? At the rate of 14.3%, so rate is your R, hello, there's your R, per year. Okay, we don't know how many years yet. We haven't read the whole problem. Okay, so this is a decrease problem. Let me just give you a little life pointers here. Very few things in, possessions, very few material possessions increase in value over time. Very few. Gold does, and maybe silver, they increase, okay? The precious jewels, okay? There's diamonds and emeralds are considered the precious jewels. Rubies, sapphires, and all that kind of stuff. I don't know if they're considered precious. But so maybe diamonds and gold and silver, they increase over time, okay? The price of gold just keeps going up, 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 up. Okay, maybe a super fancy, schmancy car. A Ferrari, if you took really good care of it, didn't drive it much, that kind of stuff, okay? But now normal cars that we drive every day, what happens to them? Yeah, they depreciate in value, don't they? You buy a couch for $800 and in, 6, 10, 12 years or whatever, you're wanting to sell it in a garage sale, you're not going to get $600. You'll be lucky to get, $75 for it, right? In a garage sale, right? So most things decrease in value. Okay, but this says this computer is decreasing in value. That makes sense. It was bought for $6,500, so that's a pretty expensive computer. But, there was a time that computers cost that much, probably when this word problem was written. Okay, so we have y equals ab to the x. That's our main equation. We got to plug stuff in. Okay, so it started out at 6,500. Now we have to figure out what the b is. Well, when it's depreciation, when it's decay, your b is 1 minus r. Okay, so we take 1 minus, and you have to move your decimal over twice, okay, 0.143. Okay, well, I can't do that one in my head, so type 1 minus 0.143 in your calculator, and that's going to give us our B. 1 minus 0.143. What is it? 0.857. So that's our B, 0.857 to the x power. They still haven't told us the time yet. Okay? Okay. So when it's growth, your B is 1 plus R. When it's decay, your B is 1 minus R. You have that written in several places in your notes, okay? So find the value of the computer after 3 years. So now they're giving us a time. 6,500 times 8.57 to the third power, because that's our time. So type that in your calculator. And let's see what we get. Okay, 6,500 times 0.857 raised to the third power. Enter. Okay, so this computer after 3 years is worth $4,091.25, right? I rounded up this 8 and made that a 25 instead of a 24. Money is in, 2 decimal places out. Okay? Okay, so it's just going to take you practicing. You do have to be careful on back over here. Okay? Back over here. We can get it to change pages. Back over here, if your growth factor is kind of bigger than, if your growth factor is something big, subtract a 1. Okay, like this one. Okay, subtract a 1.